have forces. So we are determining. So remember, the textbook statics, they want you to make sure that you're comfortable finding resultants, right? Which means you're first not doing statics problems, right? You find out they first want you to make sure you know how to solve for resultants, which is really a dynamics problem, it's moving. And then you get to statics. Okay. I think on the exam there's probably going to be 3 statics problems and 1 resultant problem. Or maybe only statics problems, because when you do the statics problems, you're going to have to find resultants and you're finding components. So you want to make sure that you're practicing the statics problems. Okay, now we're getting to moments. So the first thing we do is I'm going to make sure that you know how to calculate moments first, and then we'll do statics problems where we're preventing that rotational motion. John?
I was just wondering, for like the exam and homework and stuff, how far in terms of showing our work do you want us to get before putting it in and being able to use matrices?
Oh, you just need to show me the equations,
Okay.
right? So you do the whole setup, you show me the equations, and then just write down, use the calculator, and then just use the calculator and say t equals this, s equals this, whatever. Good question. Okay, so when I am trying to find, and I know in physics you call them torque, right? So in engineering we use the term moment, and moment is the torque on something. And how do you calculate moment? It's the force times the distance, right? And it's the absolute value of the force, you see my designation for absolute value, times the absolute value of the distance, the perpendicular distance. So first, let's say, is a moment a vector or a scalar? It's a vector. How come? Because it's a cross product. Good, nice math answer. Why? Give me more details. Why is it a vector? It has a magnitude. It's spinning 100 inch-pound, and it has a direction. So if I am calculating the moment here as a vector, and that's all I'm doing is multiplying the magnitude of the force times the magnitude of the perpendicular distance, did I get the magnitude of the moment?
Yes.
Yes. Did I get the direction? No. So our direction, you know, is counterclockwise is positive. So if you put your hand up, thumb's pointing out at you. The thumb tells us our spin. This is what? Positive. This is negative. Positive. Do it. Positive, negative, positive, positive, negative, 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 positive, negative, positive, 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 negative. You got positive and negative, right? Okay. So let's do a problem. So we are looking at problem number 1. And we are trying to find the moment about point A. Here's point A. We know it's the magnitude of the force times the magnitude of the perpendicular distance. So what is the force in this problem? 100. And what is the perpendicular distance from the force to point A? Okay, I want everybody to say what the distance is. What is the perpendicular distance? Here's the force. Here's point A. What's the perpendicular distance between the two? 5. What's the units turn out to be?
Inches.
Inch pound. So it comes out to be 500 inch pounds. You know what's kind of interesting? Hang on a second. The units in the English system, we say inch pound. We say foot pound, right? Pound inch, I think now would sound weird to you. Pound inch, pound foot. Doesn't that sound weird? Right? Like some physics and then just real world. So notice the distance goes first. But in metric, what do you say? Newton meter. Doesn't that sound right? Meter Newton doesn't sound right. Kilonewton millimeter, kilonewton meter. So this is how it's used. Okay, so the vernacular is you always say the distance first, then the force. So what I wrote up here, it's 100 times 5, and it's 5 inch-pound. So now, we do direction, because we only have the magnitude. I want you, and I know you guys do it a variety of ways, so you can do it every way you want, but if you keep screwing up, then do it my way. You put your fingers in the direction of the force. You put your palm where the point is. And is your thumb sticking out at you?
Yeah. Yes.
Force goes in the direction, the fingers go in the direction of the force, palm goes to the point you're trying to find the moment about. Are you getting positive or negative? Positive. Okay, Spencer, question.
I was just going to ask about units, if you want us to leave it in whatever we start with. So since it starts in inches, we stay there, or
Yeah.
foot-pounds there?
Yeah, there's no need to change. I mean, sometimes I change from millimeter to meter because I'm dealing with 3 decimal places, and that's just too many zeros to do. So then I'll typically change from millimeters to meters, but you could do whichever one you want. Okay, now let's do the moment about point B. So again, it's the absolute value of the force. What's the force? 100. What's the perpendicular distance from the force to B? 10. So it comes out to be 1,000. It's inch-pound. Same thing. Fingers go in the direction of the force. Palm goes towards the point. Do I get a positive or a negative? Negative. Now, is this problem a 2D problem or a 3D problem? 2D. That means my x-axis is going this way and my y-axis is going that way. What is the spin about? How is this spinning? What axis is it spinning about? So let's see. The force is in which direction? Y. The distance is in what direction? X. And somebody already shouted out earlier that it's a cross product, right? Moment is vectors cross the R cross F. You know the cross, maybe you don't. The cross product, the result of a cross product of 2 vectors is a vector that is perpendicular to the 2 vectors that are in the problem, right? So if we think in terms of math, we're crossing an X with a Y, we got to get a Z, right? But just think about it. I have my force going here. Here's my distance. I'm spinning in the Z-axis that's coming out at you. It's a spin in a Z, so we should really put the K in here. Does everybody get that? Force is in the X, force is in the Y, distance is in the X. I'm spinning like a, what do you call it, pinwheel. And where is it spinning? When I'm trying to find the moment about A, if I took a nail and I put it in here and I attached a string to the force, it would spin around A, counterclockwise, positive. If I put a pin in here, tied a little piece of string to the force, it's spinning this way. The 5 is the perpendicular distance between the force in question and the point I want to find my moment about. Okay, do the next one. start doing it. So the moment about A, it's the absolute value of the force, 150, times what is the perpendicular distance from the force to A?
0?
7.
Oh.
Okay, look up here. Here is my force. Here is point A. What is the perpendicular distance between these two? It's 7. Charlie?
I thought that was parallel to the, oh, never mind.
No, it's perpendicular, right?
Okay.
So what you need to do is, what I find comfortable is putting a big old arrow here. And then I look at the point I'm thinking about and what is the perpendicular distance, which is really the shortest line distance between that point. 7. What's 150 times 7? Times 4 is a, what is it? 10? 1050. And what's the units? Inch, pound again. What direction is the spin in? IJ, okay? The force is in which direction? Everybody tell me. The force is in which direction? X, a negative X. What's the distance in? Y. So the spin has to be about the Z-axis. And we put our fingers in the direction of the force, palm towards the point, and do you get a positive or negative? Positive. Okay, B. The force is still 150. What's the perpendicular distance between B and the force? 7 again. 10, 50, K, inch, pound. Positive or negative? Fingers go in the direction of the force. Palm goes towards B. It's positive. And the moment about C is? And why? There's no distance. So what's going to happen to point C? You're telling me that this force at C does not create a moment, but what does it do to it? It pulls it. It causes translational motion. It doesn't cause rotational motion. So the force is going in this direction. My point is right here. So again, you picture a pin in here. I have a string that's connected to the force. It's going to go around. It's going to create a positive. Same thing here. Pin, string, positive. Is this on the first exam? No, this is new stuff. Okay. I still owe you 5 minutes, I believe. Okay, so